Hey guys, this is the Integrated Science Unit 4. We are in chemistry. We are on skill 3, the types of chemical equations, part 2. And today we're going to talk about energy. Okay, so the first thing you need to know is that if you're looking at a molecule, there is energy stored, chemical energy stored in the bonds of a substance. So like here's a molecule of water, right? There's energy that's taking that hydrogen and making it stay stuck to that oxygen. So in every single bond you see here, there's energy. Energy is the ability to do something. So there's energy stored right now. It's the ability to stay attached. So chemical reactions always involve energy changes because chemical reactions involve breaking bonds, and it takes energy to break a bond. So EA is a symbol that means activation energy. So E stands for energy, and A is labeling what type of energy, and it's activation. So this is the energy required to break the bonds and the reactants for a chemical reaction to occur. Remember, you have molecules, and the atoms have to come apart if they're going to find their new partner to make with the new substances, the new products. So it's like if you have these two hydrogens connected, you have to put energy in to break them apart. Once they're broken apart, these hydrogens can bond with something else. In any chemical reaction, the atoms rearrange to be bond with new partners. So you have to break the bonds that they have first to make new bonds. Otherwise, they'd still be stuck to the same thing. So you have to input energy all the time. So here we have hydrogen and oxygen reacting together to form water. So you have to break these bonds that are between the hydrogens and oxygens so you have free atoms so they can reform. Notice this oxygen is stuck to another oxygen. I don't see an oxygen stuck to another oxygen over here. So I had to break that bond to make a new one. In the middle, this is called the transition state. It's the state when all the old bonds have been broken, but the new bonds haven't formed yet. And it's an unstable, very high energy. So some of you guys played with this ball last class, and I asked you to change it to the other color without pushing or pulling it. And to do that, you have to throw it up in the air. See, now it's pink. So that openness up in the air, that's the transition state. That's that really high energy state. And when I mean high energy right now, I'm throwing it up. That's where you see the transition state. You can't keep it up in the air. It has to come back down to either be, it stayed pink, blue or pink. So it can't be in that open state up in the air for long because it doesn't stay up in the air, kind of like the transition state. The transition state, this middle part right here where the bonds have been broken but new bonds haven't formed, it's instantaneous. It's that for a brief moment of time and then it will automatically jump to the new bonds and make your products. So if you have an exothermic reaction, the term exo means to release, right? You might go to an exit to leave, and thermic means heat. So if more energy is released than is supplied, the reaction is said to be exothermic. So energy exists or is a product in this reaction. So for example, if you have a fossil fuel like gasoline and you have it with oxygen, it can burn and you have heat that comes off of it as energy. So look at this, if you look at this chart here, here are your reactants. You put in EA, the activation energy. This is where your transition state is. And then when you make your reactants, the bonds in the reactants have less energy, so that energy has to be released. And if you have a reaction that's exothermic, that's releasing energy, it's going to feel hot. If your hands are around it, that energy gets released and absorbed into your hands, so it feels hot. So energy cannot be created or destroyed, so energy has to leave the system. If you have more energy in your reactants than you have in your products, meaning in the end you have less energy, that energy had to go somewhere. It exited the system, exothermic. So exothermic reactions feel hot because they are releasing energy and then you absorb it. So here are the energy of the reactants. This is the energy stored in the bonds. Then you have to put in energy. This is the activation energy. That's the energy it requires to break all those bonds in your reactants. And then this is the energy that's released from here to here, but this is the difference. So this is what's released as heat. The next is endothermic, still thermic, meaning heat, but endo means to take in. So if more energy is absorbed than supplied, the reaction is said to be endothermic. So energy enters or is taken into the system that the reaction is doing during the process. So for example, this is photosynthesis, right? Carbon dioxide and water plus energy. You get energy from the sun, makes glucose and oxygen. So here's our chart. Notice the reactant's energy is low, the product's energy is high, which means it had to take in energy. So the products have more energy than the reactants because energy was taken in. And these feel cold. If you put your hand on the outside of a beaker while an endothermic reaction is going on, that reaction is going to pull heat from anything around it, which is from your hands. There is actually no such thing as cold. I know this blows your mind. The only time you feel cold is when you're losing heat, okay? So if something is endothermic and you touch it, it's pulling the heat out of your hand and taking it into that system. So that's why it feels cold. That thing is taking in heat. So again, here is the energy of the reactant. So this is the energy stored in the bonds. And then here is your activation energy. Always from the reactants to the top of the hill, that's the activation energy, energy used in the bond breaking. And here is the energy that is absorbed in the reaction. Notice this little bit is being released again. So from here to here, the difference between reactants and products is how much energy is being absorbed. And this is energy that's released in the bond making, the difference between the energy of the transition, that high energy state, and the energy of the product. Okay, best of luck on this section, and I will see you in the next set of notes. Let me know if you have any questions. All right, good luck.